Hello everyone, this is the video for lesson 9.3, geometric sequences. Go ahead and grab your highlighter because you're going to need it. Okay, so first thing we're going to talk about is what's the difference between an arithmetic and a geometric sequence. So an arithmetic is when you are adding a common difference. So if you add a positive number, it is going to increase. If you add a negative number, it is going to decrease. And if you look at the data, like if you graph the sequence on Desmos, it is going to be in a straight line. So it is basically linear. On the other hand, a geometric sequence is going to follow an exponential pattern. So exponential, remember, can either have a growth to it or it can either have a decay. So clearly not in a straight line. You know it's going to be a growth if you're multiplying by something larger than 1. It'll be a decay if you multiply by something between 0 and 1. Okay, so let's get into the actual sequences. So in a geometric sequence, let's go ahead and highlight the word geometric. The ratio between the pair of consecutive terms is the same. Now notice they call it a ratio. It's called a common ratio instead of a common difference. Difference insinuates that you are adding or subtracting, and then a ratio means that you are comparing by division. So if you wanted to find a common ratio, what you're going to do is you are going to take one of the numbers in the sequence and divide it by the term before it. So just a really basic way to figure that out is take that second term. So a sub 2 means 5. That's the second term divided by 1 is 5. So that means what you're doing is you are multiplying each term by 5. And that's how you find the next few terms. We're not going to do that just yet. We're going to actually try to figure out what these sequences are before writing any terms if they do ask us to do so. So one more time, highlighter. Arithmetic sequences are going to have a common difference. That means that you are adding the same number. You are going to need to know how to find a common difference because that is not on your formula sheet. Geometric sequences have a common ratio, that is by multiplying the same number to each term to find the next one. Once again, common difference, common ratio, you have to find them on your own. There's nothing on the formula sheet that tells you how to do that. If you cannot find either of the two, then you are going to answer that it is neither arithmetic or geometric. So I like to say work smarter, not harder. So instead of just blindly going into it, just checking for a common difference and then a common ratio, I need you to just kind of look at the sequence and see if you can figure out if we're adding the same amount. Now, if you start with 120 and you go to 60 and then you go to 30, that difference is absolutely getting smaller and smaller and smaller. So I absolutely know that this is not arithmetic. Okay, so I'm not even going to show it to you because like you can do this in your head. Like this is plus negative 60 and then this is plus negative 30. So I'm not even going to write it down. Now I suspect that it is actually a geometric sequence. I feel like it's got a common ratio. So I'm going to find the common ratio by dividing the second term by the first term. Okay, so that's going to simplify to 1/2. I'm going to leave it a fraction. It starts out as whole numbers, so I guess it really doesn't matter if you write it as 1/2 or 0.5. So the common ratio is 1/2. You need to verify. You need to make sure that each term is being multiplied times 1/2. So I know it's true for the first one. Is it true? For 60, 60 times 1/2 is 30. Yes. 30 times 1/2 is 15. Yes. So that is absolutely going to be a geometric sequence. So go with what you suspect it is going to be, test it, see if it works out, and then go ahead and decide. All right, so now in the second example, it feels like we are adding the same amount to each number. I don't think it's exponential. It's not growing really quickly. So I'm going to try to find a common difference here. And the common difference is going to wind up being 6 minus 2. So 6 minus 2 is 4. Am I actually adding 4 to each number? So 2 plus 4 is 6. Yes. 6 plus 4 is 10. Oop. So no, it's not going to be a common difference. There's no way this is going to be arithmetic. I really don't think this is geometric at all. So if you look at this, let me go ahead and erase. So the common ratio, I'll just prove it to you this time. So the common ratio is going to be 6 divided by 2. So that's 3. Am I multiplying by 3 on the first two? Yes. This is why you need to verify. Times 3, that is supposed to be 18. That does not work either. So I don't have a common difference. I don't have a common ratio. So number 2 is neither arithmetic or geometric. Okay, so now is the time that I'm going to give you 3. I want you to try to figure out whether it is arithmetic or geometric. Now seriously, like if you're watching this video in class, you need to pause the video. And I want you to try it because I know several of you aren't going to do your homework. And this is really the only time you're going to need to practice it. So please pause the video and unpause when you're ready to check these 3 answers. Okay, so on A, this one looks like I might be adding the same thing. So I think this might be arithmetic. I'm going to put a big question mark here. If it's arithmetic, I'm going to have a common difference, and the common difference is the second term minus the first one. So 4 minus 7 gives me -3. Am I adding -3 to each number? Well, obviously it's going to work the first time. Yes, the second time. Yes, the third time. So yes, this is arithmetic for sure. Okay, part B. I see how I've got a huge jump between these two numbers, but the jump's getting smaller and smaller. So I don't think this is arithmetic. I suspect that this is geometric. So if I think this is geometric, what I'm going to do is I'm going to try to find the common ratio. The common ratio is the second term divided by the first term. So if you simplify this using your calculator or your head, you wind up with 1/4. Am I multiplying by 1/4? I am the first two for sure. 48 times 1/4 is 12. 12 times 1/4 is 3. So yes, this is geometric. Final answer for part B. Okay, last section, I have 5, 10, 30. So it looks like I could be either adding 5 or multiplying by 2. But this does not continue. So if I add 5 here, no. That doesn't work here. If I multiply by 2, no, because that should be 20. So this isn't going to work. It's definitely going to be neither because it doesn't have a common difference or a common ratio. Okay, so in this next part, it's asking you to extend a geometric sequence. So when I extend the sequence, I need to find the common difference because it tells me it's geometric. So I said the wrong thing. It should be the common ratio. Sorry about that. So the ratio is going to be a sub 2 divided by a sub 1. So the second term is -16. I'm going to divide that by 64, reduce that to -1/4. So since I know that it is definitely geometric, that is going to be the pattern that continues. You're going to take this -1 here, and you're going to multiply that times -1/4. And you get -1/4. And then you take -1/4, repeat the pattern. So this is your common ratio right here. You're multiplying each number by -1/4 to get the next number. And then I'm going to finish it out. This 1/16 is now over here. I'm going to multiply by -1/4, and you get -1/64. So the next 3 terms, final answer, it's going to be positive. And notice that whenever you have a common ratio that is negative, your numbers alternate signs. So -1/4, +1/16, -1/4. That's basically it. Find the common ratio, multiply to find the next 3 terms. It is now your turn. Once again, please practice this. So stop the video. Don't just copy it down. Stop the video. I want you to try to find the common ratio and unpause when you're ready to check your answer. All right, we are going to check this you try question. We got some fraction fun in the front, so they told us that it was definitely going to be a geometric. So I'm going to find the common ratio by dividing the second term by the first term. You absolutely are allowed to use your calculator to do this. Just be really careful how you type it in. Whenever you divide these two fractions, you wind up with -3. That's not too bad. So you're going to take the last term right here, which is -6, and you're going to multiply that times your common ratio. That's going to give you 18. 18 times -3 is -54. You see that alternating sign. And last number is 162. So final answer for the next three terms, 18, -54, and 162. Okay, so this next part is you just being able to write the geometric sequence rule. This is on your formula sheet. It is very, very, very close to an exponential growth or decay function, except for the ratio here. You find the ratio by dividing consecutive terms, okay? So it's different. So if it's a growth, so if your ratio is greater than 1, it's going to grow. It's going to get bigger naturally. And if your ratio is between 0 and 1, not negative, if it's between 0 and 1, it's going to decay. One thing about a sequence, though, it can have a negative ratio. An exponential growth or decay cannot, because a sequence is discrete. You have individual points. So if you have, positive, then a negative, positive, and then negative, it looks crazy on a graph. It's like this, and then this, and then this, and then this, and that's not going to be a function anymore. So we don't connect those dots. But anyway, so let's go ahead and get into it. For you to be able to create this formula, you are going to need to substitute the first term, and then you are going to have to substitute that common ratio, and the good thing is you know how to find everything. Okay, so let's go ahead and find the common ratio, and we're going to write down the first term. So the first term is really easy, you just have to look at it. So the first term is 2. Common ratio, on the other hand, we are going to take the second term and divide it by the first, and we get 6. Okay, this one's a little easier than the arithmetic rule, because the arithmetic rule, you have to simplify it. This one, you do not, absolutely do not simplify it. So I'm going to write down the generic formula. Now, see these two things right here? They are being multiplied, so you're going to have to show that either by using a dot. I prefer to use parentheses, so I like to do that when I'm writing my answer. So we're going to do a sub n. We have to use n here because it's generic. But a sub 1, on the other hand, that is the first term. You have to plug that in here, and then your ratio was 6. So I like to use parentheses and then finish it out by putting in -1. That is the rule. The rule is handy when you are not doing the next three terms, like if you're doing a term pretty far down in the sequence. So in this case, I'm trying to figure out the 10th term. So it is much easier for me to just go ahead and plug in 10 for n than for me to carry out 10 terms. Okay, so simply just type in 2 times 6 to the power of 10 minus 1, or you can just change that to 9 when you're typing it in. We get a very large number because this is growing by a very large amount. If you're multiplying numbers by 6, the numbers are going to get really big really fast. And fun fact, for your end of course, for your ACT, anything that grows exponentially means that you're multiplying by something. That is the fastest growing function. All right, if you want to pause the video, if you're feeling pretty confident, you can here. You don't have to. I like to do 2 examples for you. So I'm going to go ahead and just straight on and do this example. So we're going to find the common ratio, second term divided by the first term, and that is going to give us -2. And we also need to identify the first term, which is 0.1. All we have to do is substitute into our generic formula, and we're going to leave n. So a sub 1 is 0.1, and this is why I like to use parentheses, because the dot's going to look confusing with the decimal. So I'm going to put -2 in here and -1. So this is my generic rule. What this rule will do is it will find any term for you in the sequence, including the 8th term, which is what they want you to do here. So I'm going to take 0.1 times -2 and then plug in 8 minus 1 in that. So in the calculator, I would just say 0.1 times -2 to the power of 7. And that's going to give me -12.8. So that is how you write a rule and then find any number in the sequence. Okay, so let's do one that kind of has context to it from real life. So it says clicking a zoom out button on a mapping website doubles the side length. So when somebody says that they double something, we are multiplying by 2. And you can see this in this chart right here. So we're going from 5 to 10 to 20. So 5 times 2 is 10. 10 times 2 is 20. So if you look at the table, look at your y values, that's how you can find your common ratio. Just to show you real quick, the 10 divided by 5 does give you 2, so that's R. Your first term is absolutely going to be that 5 right there. It's not the 1, because remember 1, 2, 3, that's kind of the position that the numbers are in, first term, second term, third term. So the first term is 5. So just from this information here, I have enough to actually write a function. And the reason why I want a function is because I'm going to have to use that function to find something far out, okay? So I'm going to write the function. I'm going to start with my generic, just like I did last time. Okay, so a sub n gives me 5. That's my first term, times the ratio of 2 and minus 1. This is the function, or the rule. Let's put function rule just for fun. Okay, now it says to answer the question. It says, how many clicks? So we're looking for this number right here. How many clicks? We normally, provide you, well, what's the side length going to be after blank amount of clicks? So instead of you finding like a sub 10, what they're doing is they're giving you what a sub 10 would be equal to. So what is this sequence going to result? What is that number, the n value? So if we're trying to find the output, it's going to be equal to 640 miles. We're not trying to find the 640th term. It's going to be what term is equal to 640. So here's what you're going to do. Because we don't know how to solve this, what you're going to do is you're going to split this into a left and a right side. This works for all equations that we don't know how to solve. So you're going to say y equals 640. You're going to say y equals 5 times 2 to the power of n minus 1. What you're going to do is you're going to type that into Desmos. Okay. Now, don't get me wrong, you can do this by hand, but you have to be really good at logarithms. So if you have been taught how to do this using logarithms, perhaps you were in the honors class or you were transferring from somewhere, then you should know how to do this by hand. Okay. But I'm not going to show you in this video. So if you want to ask me, feel free to ask me. But in Desmos, go ahead and type these two in, and you're going to have to zoom out so you can see where they intersect. So I'm going to draw you a nice little picture real quick. So this first one's going to look like this, and the second one looks like that. And you're going to have this magical little point right here. And what that's going to do is that's going to tell you exactly what your answer is. Okay, and when you click on that in Desmos, it tells you that it is 8,640. Remember, this is your term, like what it's equal to, and then this is the position right here. So if you click, so what this means, if you click on this map 8 times, your map length on the side is going to be 640 miles. So we're going to answer the question. It's going to take 8 clicks. And that's how you do it. Okay, so the last 2 questions here are kind of a lesson in make sure that you verify that it is either arithmetic or geometric. So remember when before when we were doing the sequences, I'm like, suspect. What do you suspect that it's going to be? Well, I suspect that this is a straight line. It looks pretty close that it's a straight line. So I'm going to check to see if it is arithmetic. And the way that you verify if it's arithmetic, we are going to look at the y values because those are the actual sequence numbers. So I have a 2, 12, 21, and 29. So 2, 12, 21, and 29. And if it's arithmetic, it's going to have a common difference. So the common difference is a sub 2 minus a sub 1. So 12 minus 2 is going to give me 10. So what I need to do is I need to verify that I am, yes, adding 10 to each number. Oh, wait. No, that should be 22. No. And then this one looks like it's adding only 8 here. So no, this is not arithmetic. This is not geometric either because you're not multiplying. So you can see 2 times 12 is times 6. Sorry, 2 times 6 is equal to 12. But then if you say times 6 again, that is way bigger than 21. That is not going to work. So this is definitely neither. So I suspected that it was arithmetic. It is not. Verify your answers. Next. So this one is showing a very clear decay type pattern, but is it perfect? I don't know. So I suspect that this is geometric. If it's geometric, what we're going to do is we're going to look at our terms in order to see if I am multiplying by the same number. So I'm going to take 72 and I'm going to divide that by 144. That gives me 1/2. You need to verify it. Of course, it's going to work for the first two, but 72 times 1/2 is 36. That is not 24. So that's a no on geometric. It is absolutely not a straight line. I know this is not arithmetic either. So one more time, I have neither. So be really careful. Just by looking at something does not mean that it is something. All right, we are done. And as always, please take you some time to practice and just let me know if you have any questions.